Welcome to another Trailmakers tutorial video. Today we're going to be covering flight stabilization systems thanks to a viewer request. They wanted to know how my gunship stabilization worked, so I'm going to teach you. This here is the Tadpole gunship, and it's equipped with the Mark 18 artillery system. But the weapon's not really important right now, although I will link in the description a tutorial that I have on how to make them. But anyways, the flight stabilization is obviously it holds its position up and down in the air really well. Wherever you leave it at, it'll maintain that position. But also, if you're strafing or moving forward, then let go of the controls, it'll automatically come to a stop and hold position again. And holding position is very handy for the artillery system for long-range attacks and attacking the same place twice without losing your aim. But anyways, on how these work. So you'll notice I have this little guy over here, and that's mostly to show that it's not going to take a whole lot of logic or anything like that to make this work. The only reason this is so big is because the weapon system is big and heavy. So it needs a whole bunch of thrust and everything to keep it going. But this little guy is literally just the same thing shrunk down. And if we go into build mode, thanks to its piston glitch, you can see its guts. There's a little bit of logic in here, but it's not too bad. It's just 3 pieces of logic for each direction we're stabilizing in. So it adds up to a decent amount, but each module is pretty simple. So let's get to building them. So we'll start with a seat, then make a little platform for our demonstration vehicle. And next we'll grab some thrusters. I'm going to use space thrusters because I use them a lot. They're nice and efficient. And I like the way that their connection points are. And next, we're going to grab our logic pieces. First and most important, we have the speed sensor. And I say most important because this one, it matters which direction it's facing. So we want our little fan upwards so that we can sense any velocity in the upwards direction. Next, we're going to grab a NOR gate. That's the NOR gate. And then an AND gate. Next, we'll configure our speed sensor. So we're going to set the speed to 0.2 and have it trigger below. And we're going to attach that to the AND gate. Then the NOR gate gets a green input of L2 and also gets attached to the AND gate. Then we select the AND gate itself and connect it to all of our thrusters. Then we need some angular stability, so we're just going to go the simple route and put some gyro stabilizers on here. And bring their strength up a little bit so that we don't tip over. And now we have the logic to hover and go up and down and maintain our position. Now our horizontal stabilization is pretty similar. There's just a slight difference to it. But first, we'll grab some more thrusters. We don't want to just copy these thrusters because they already have logic attached to them that we would have to unwire. So it's actually faster just to grab fresh ones. And we're going to have 2 facing in each direction. Next, we'll grab some fresh logic pieces. Speed sensor. NOR gate. And AND gate. Next, we'll copy this logic so that we have a speed sensor pointed in each direction. Oh, that one already flipped. Next, we'll set up the controls for our thrusters. So we'll select our rear thrusters and give them a forward input. Select our front thrusters and give them a backwards input. Select our right thrusters and give them an L1 input. And select our left thrusters and give them an R1 input. Next, we'll select all of our speed sensors. And we're going to bring their speed down to 0. And we're not going to have them trigger below. So they'll trigger as soon as they get any speed whatsoever, and send a signal then. And we'll start in the back here. We'll wire up the speed sensor to the AND gate, the NOR gate to the AND gate, and the NOR gate gets controls in the direction that the speed sensor is facing. So in this case it'll be backwards. And then the AND gate gets attached to the jets on this side, which have the opposite controls. So these are our forward thrusters, which makes sense because if we have any speed going in this direction, the way our speed sensor is facing, in order to cancel it out, we use these thrusters. So an easy way to make sure you've got your setup correct is that if your NOR gate's control is the opposite of the thruster hooked up to it. But we've got 3 more to go through, so I'm sure you'll get that. We start with the speed sensor, connect it to the AND gate, take the NOR gate, connect it to the AND gate, and these ones are going to be forward. Then we connect the AND gate to the backwards thrusters. Now onto the sides. So the left-hand speed sensor gets attached to the AND gate, the NOR gate gets attached to the AND gate, and we get L1 on the NOR gate control. And attach the AND gate to the R1 thrusters. And of course, pretty much the same thing on this side. The speed sensor to the AND gate, the NOR gate to the AND gate. We're going to have R1 on our NOR gate, and we're going to connect that to our L1 thrusters. So now, we have something that hovers in place, wherever we leave it at, can strafe side to side, and automatically stop itself, and move forwards and backwards, and automatically stop itself. And if we just plop a gyro on top to give it some turning power, now we have a functional craft. Now that just about wraps things up, but I do have one more example to show you, and that's this one right here, which is to demonstrate that you don't need the angular stabilization of the gyros. You can have something that freely rotates around, and in this case, when it comes to our upwards and downwards speed sensors, we do them exactly the same as we do the sideways ones. We don't do the 0.2 method. And that's because we already have an opposing force to keep it in check, so that we don't accidentally rise or fall, which is the reason why we have this one trigger at 0.2 in the upwards direction, even though all the other ones, the speed sensor is facing the same as the jets they're hooked up to. And that's just so that you can tune it if you need to. So if your craft weighs a little bit too much or too little, you might have to bring it down to 0.1 or up to 0.3. But 0.2 is a good starting point and usually the best balance point. But like I said, if you're stabilizing in every direction, you don't need to worry about that so much. Although we are sinking a little bit, it looks like, in this one. Yeah, you can see that we're getting closer to the floor right now. Whereas our little flying carpet over here, if we go down to the ground, you can see we're actually slightly rising. But the other thing here is you'll notice that there's gimbals in here, and that's just to take up a little bit of the weight. Because there's only so many thrusters active at a time producing downwards force, and the rest of them are just stabilizing in all the different directions. It kind of weighs a lot. So these aren't actually anything to stabilize it at all, they're just gimbal jets with no logic attached to them other than a NOR gate to keep them running. But this thing can move in any direction, so there's the front of it. I was trying to remember which color was the front of it. It's yellow in the front. But we can also strafe side to side and move up and down. And as soon as we stop any of our controls, it immediately goes back to holding its position in the air. And like I said, this is all using the same circuitry that we used on the sides of this one over here. But I think that about wraps it up. If you have any questions, leave a comment. And if you want to support the channel or just make me happy, leave a like and subscribe. Anyways, bye-bye now.
PlayStation